While the example we did a little while ago gave us 2 over 5 as the opposite over hypotenuse, that doesn't mean that the angle measure is 2 over 5. While that would have been a pretty easy system to work with, where, all right, the ratios will give us how we measure our angles, and somebody would have made a protractor where 0.4 or 2/5, I guess it would be decimals would make more sense, 0.4 would represent this angle measure. That's just not how it is. There are 2 ways that we'll focus on measuring angles while in high school. One of those ways is using degrees, and another way is using something called a radian. If we wanted to find the degree measure with this information for the triangle we saw in the beginning of the lesson, we can use a calculator to do that. With limited explanation, I will show you what it is you need to do with that 2/5, and we'll see more about that in a future lesson, but let's just give you a little sneak peek on what's to come. All right, so we are back here with our original example. I'm assuming we've all seen a calculator before. If not, this is a calculator. Many of you have probably seen the buttons that I'm pointing at right now in the past. So we do have SIN, sign, and we have those 2. We'll talk about them later. But there's our sign button. We just wrote down the definition of sign. So before I use the calculator, I'm going to just write out the equation or function that would apply to this example here. Before we begin using the calculator, I need to write out the sign function for these examples right here. I'm going to focus on the red triangle. Not that it makes any difference, because the black triangle and the red triangle actually have the same sign ratio. An equation I could write down would be sine of theta equals opposite, which is 2, over hypotenuse, which is 5. What that tells me is if I take the sign of the angle, my answer will be 2 over 5 or 0.4 as a decimal. Think of sine as a square root. When you take a square root of a number, for example, 4, the square root of 4 gives you 2. But this is almost saying the square root of what gives you 2? The square root of something gives you 2. Instead, we have the sine of something gives you 2/5. If I said to you the square root of something gives you 2, how would you work backwards and figure out that the missing number is 4? If you said use the inverse operation, you'd be right. If you also said to square both sides, you'd be right. While some of you think I just know the answer in my head because I'm a genius, that's sort of not true. You subconsciously did square the 2 and got 4. Using an inverse operation helps us solve for an unknown when it's in an existing function. While sign is a word and not a symbol, it is still a function operation. Sometimes we square something In this case, the function operation is squaring. In this case, the function operation is a square root. Here, my function operation is something called sine. Now, long ago, people sat around and figured out what angle measure would correspond to many different ratios, and they stored them in a huge table. So whenever someone needed to know, well, what angle goes with this ratio, 2/5, they would look at one of these tables. And they would find out which angle measurement, for now we're going to work with degrees, what angle measurement in degrees would allow for the ratio to be 2/5 or 0.4. I'm going to take a second and show you one of these tables now. So all I did was search in Google Trig Table, and I found a bunch of PDFs that show me the table that I actually used in a textbook when I was in high school, even though, yes, calculators did exist when I was in high school. But we did reference these tables from time to time. So if you look at this table, it has sine right over here. These are the other trig functions that we'll talk about later. And this one's a pretty lousy quality scan, but we do have a few other options. So here is another one, and one more. I tend to gravitate towards this one. I like that it has a little bit of color to break it down. It doesn't have all 6 trig functions. It has 3 of them, and it has sine, which is the one we're looking for. So I did mention that we can measure angles in degrees and radians. We didn't learn radians yet. You should have a pretty good understanding of degrees if you're in geometry. So the ratio I had for sine was 2/5. And we said that 2/5 is equal to 0.4 as a decimal. The way you would get that is either divide 2 by 5 using long division, using a calculator, or maybe you just had it memorized. Or you could think that 2/5 is really 4/10, and 4/10 as a decimal is 0.4. So what I need to do is find where sine is equal to 0.4. If I scroll, I'll see that my sine ratio, which is opposite over hypotenuse, gets bigger as I scroll down. And there's another column here, but one thing at a time. As I scroll down and it gets larger, I'm kind of thinking about it. As my ratio of opposite over hypotenuse gets bigger, maybe even think like your opposite side grows and your hypotenuse stays the same, thus making your ratio larger in size. Your angle will also get bigger. So right over here, you'll see that while 0.4 exactly is not on the table, we can at least estimate that it's going to be somewhere between 23 and 24 degrees, as long as we're in the right column, I believe, right? Yes, sine was here. The radian measure and the sine, if you look closely, very, very, very similar. So it's very easy for your eyes to jump accidentally to the wrong column. So you do want to be careful of that. So here, going back to what we were just looking at, my sine column, we went down to look for 0.4, and we see that that would put us somewhere between 23 and 24 degrees. And that is more or less how this table would work. But while this is handy, and I do think it would be a pretty good idea to even just print one and stick it in your notebook for quick, easy access when you don't have a calculator handy, or sometimes typing into an iPhone calculator, or when you borrow a calculator from someone, the buttons and the way the functions work can vary from calculator to calculator, and it's very, very, very easy to make mistakes. So if you want to avoid just making an error in a calculator, it wouldn't be a bad idea to have something like this handy to just sort of glance at while you learn about trig now in the beginning. So we decided that our answer should be something between 23 and 24 degrees. I will link this table underneath the video, so if you wanted to print it out and have it handy, you can do that. All right? Now that we saw what it was like to use the old-fashioned trig table, which really came into existence by a lot of time spent back in ancient times, we're going to see how that translates to using a calculator in the modern day world. Okay, here we have some familiar looking buttons. Even if you've never really had to use it before, they do exist. And like I said, we will go into more detail. Here we have our sine button. I wouldn't want to take the sine of 2/5. That's not going to do anything for me. If I did that and hit enter, I'm going to get a very, very, very small number. This is 6.98 times 10 to the negative third, which is actually going to mean our decimal point is really 1, 2, 3 over. So this is really 0.00698. This is very, very silly. What this actually did is it took the sine of the angle 0.4 degrees. If you see the little G highlighted up on top of the screen, you need to check your calculator what mode it's in. My calculator is in degree mode, so this calculator is under the impression that I am either inputting degrees, or that I expect to get out a degree from a computation. That my output, I expect a degree. I could change my mode to radians, but for right now, like I said, we're working with degrees. So again, this is not correct. This is not finding our angle measure. We took the sine of 2/5, that's the ratio. What I want to take the sine of is the angle measure. However, I don't know the angle measure. How do I work backwards? You don't divide by sine, just like you wouldn't divide by a square root. That makes no sense. What we want to do is use the inverse operation. The inverse operations that we're already familiar with are pretty basic. We're already familiar with addition and subtraction, multiplication and division. We're also already familiar with squaring and square roots. Similar, we can work with x to a power and that root, and they're already on the same button. If you've taken Algebra 2, or maybe you covered it in Algebra 1, you may be familiar with the log function, which is log base 10, and here's exponential 10 to a power. An operation and its inverse happen to be on the same button. Here is the natural log, ln, and that is the naturally occurring growth factor, e, and they're also on the same button. Well, trig is no different. The inverse operation for sine can be found on the same button as sine. Here it is, sine with a little -1 in the spot that's normally reserved for the exponent. It's not raised to the negative first power. That's just notation in algebra for inverse. So instead of creating a whole new function like log and exponential, squaring and square root, multiplication and division, instead of doing that, they just got a little bit lazy and called it sine inverse right over there. So that's what we're going to use when we're finding an angle. Write that down for yourself. When finding an angle, you take the sine inverse of the ratio. I will write this down in a minute as well. To find a ratio, we take the sine of an angle. Let's give this a try. To get that yellow operation to work, or gold, whatever color that is, I'm going to press this button over here for shift. Every calculator will be a little bit different. You could see on your screen that I got that little -1 to come up. I want to take the sine inverse of 2/5, so it's 2 over 5. A fraction and division are really the same operation. I do have a fraction button if that makes you more comfortable. We could do it that way, and I'll do it like that in a second just to show you. When I hit enter, I always make sure I close off any parentheses first. I'm going to hit the equals button, and there we go, 23.57817848. Now this is not an exact answer because this decimal more than likely goes on more or less indefinitely. So this is an approximate answer. If we wanted an exact answer, we would just leave it as sine inverse 2/5. That is an exact solution because it represents the ongoing decimal, and this is approximate because we can't write down the whole thing. Just to show it again using the fraction button, I'm going to clear what's there, shift, sine inverse. There is the fraction button. Gives us some boxes to fill in. Here's 2, down arrow, 5. I'm going to move over and close that parenthesis. That might be more appealing to you. So if you like something like that, you might want to invest in a calculator like this. This calculator was definitely, I would say, under $20. I just got it at Walgreens. Okay, if I hit enter again, I get 23.57817848. Okay? Now, if I wanted to go ahead and try this the other way, what if I already knew my angle was 23.57817848? If I take the sine of an angle, I'll find the ratio. I'm going to press the sine button. And what I'm going to use now is this option down here. I have the answer button. We also have pre-answer, which is a previous answer. If I wanted to take the sine of the answer, I want to use the answer button. So I already have sine on the screen. If I press the answer button, I'm going to close the parentheses. This means I'm taking the sine of the previous answer. I didn't feel like writing it down and then typing it back into the calculator. It was the previous thing on my screen, so I'm going to try it out this way. If I hit equals, it gives me 2/5. Pretty precise. It gives me that fraction just the way I started the problem. Now let's take a look at what happens when you round instead. Here I have on my screen my angle measurement that I calculated before. I'm going to take a second to write this down. But when I write it, I'm going to round. I'm going to write down 23.6. Now what I'm going to do is take the sine of 23.6 degrees. When I used the answer button, I had a lot more information that the calculator had stored, and it was able to work backwards and tell me precisely 2/5. Now, when I close this parenthesis, when I go to take the sine, I should be getting the ratio or proportion, that opposite over hypotenuse relationship, the sine. When I hit equals, instead of giving me 2/5, the calculator has given me 0.4003490326, yada, yada, yada. Now this is pretty close, 0.400, but once we get out to the tenths, hundredths, thousandths, 10,000ths place, I'm a little bit off. Rounding can make quite the difference. So, whenever possible, don't round. Leave answers as precise as possible by leaving them in terms of sine or sine inverse. But when you're doing a word problem, if it says round to the nearest tenths place, hundredths place, etc., you just follow the directions and do whatever it says to do. But if you worked for NASA, you're probably not going to be rounding. Now, one other thing we can do. Once we know that theta is 23.6 or approximately 23.6 degrees, we can also figure out the approximate measurement of the other acute angle. How would we do that? The way we would do that is we would take 23.6 and we would just subtract that from 90 degrees. There's really no reason, it's quite silly and inefficient, to add this angle to 90 and subtract from 180. We already know that that angle is set to be 90. That means these other two are also 90. Save some time, 90 minus the angle we found, and that's going to give you the blank of the most recent angle. What is the relationship between this angle and this angle? Or, in the larger triangle, that angle there and that angle there. If you said that they were complements of each other, then you were right. They are complements of one another. Complementary angles add up to 90 degrees. It's a pair of angles. Complementary angles are two angles which add up to 90 degrees.